After a year, a teacher's investments in an individual retirement account, IRA, that pays 4% interest and a savings account that pays 1.5% interest have earned $125. The teachers invested a total of $5,000. Select pencil and paper or technology as appropriate to represent and solve this problem using matrices with a system of linear equations. And so let's go ahead and first set up our equations. So it first tells us that she pays 4% interest in the retirement account and 1.5% interest in the savings account. And those are going to add up to a total interest of $125. And so to find the interest in the retirement account, we would just take the decimal, which is 400ths, that's the 4%, and then times the amount of money she puts in that retirement account. Let's just call the amount of money R that she puts into that account. So multiplied by R, and then that would be added to the interest in the other account. So 1.5% as a decimal, that'd be 15 thousandths, and then times the amount of money she puts in her savings account. So let's call that S. So those would add to 125. And then for the other equation, then it tells us she invested $5,000. And so we know that R and S, the amount of money she puts into both accounts, should add to 5,000. So then to put that into a matrix, then we would just use our coefficients. So 400ths, 15 thousandths, and then 1, 1. And then times RS, since the R variable comes first, equals 125, 5,000. So now we can actually just use a calculator to solve this. And so remember that we're going to want to multiply by the inverse on each side. And so let's just go ahead and label our left matrix here as matrix A. So we're going to put that into our matrix A in the calculator. And then our right side here can be matrix B. Then remember that we're going to multiply by the left here. To get RS alone, we're going to multiply by the inverse of matrix A. And so let's go ahead and put in our matrices by pressing second matrix and then go to edit. So for matrix A, we'll go ahead and type in the dimensions 2 by 2 and then type in that left matrix there. And then again, go to second matrix and then edit. And this time matrix B will do the right matrix. So it should look like this. And so now we can go back to the main menu and we just want to multiply each one by the inverse. And so, by definition, the inverse of A times A will just equal the identity. And so we'll double check that and I'll just show you that that does end up being true. So you can just press matrix and then A and then press the inverse button to -1 and then times, again, second matrix and then A again. And notice it does give us the identity matrix. And then we also want to multiply this right side. So again, go to matrix A and then press the inverse button, x to the -1, and then times matrix B. And so pressing enter, then here's what we get on the right side. And so then our final answer, since matrix A on the left side will just equal the identity when multiplied, and then we'll just get RS equals 2,000, 3,000. So basically we then just know that in her retirement account, she put in $2,000 and she put in $3,000 into her savings account. So let's go ahead and summarize our answer. Represent the system using pencil and paper, but solve the system using matrices with technology. Let R represent the amount the teacher invested in the individual retirement account, IRA, and S represent the amount that a teacher invested in a savings account. 400ths R plus 15 thousandths S equals 125. R plus S equals 5,000. 400ths 1, 15 thousandths 1 times RS equals 125, 5,000. RS equals 2,000, 3,000. The teacher invested $2,000 in the individual retirement account and $3,000 in the savings account.